Okay, we're live. Let's go. So, um, I am gonna stream the development of a programming language that, sorry, one second. I'm gonna stream the development of a programming language that I want to make, right? I've always wanted to make a programming language, but I could never complete any project that I had started, so I guess I'm gonna stream it in hopes that it will keep motivating me to complete the uh, language. And because I also want to keep it simple, so what I'm going to do is I'm going to base it off of uh, the Porth programming language made by Soring, right? Right. So he basically created a stack-based programming language, which essentially works like so. If I do hello world, then it will push the string onto the stack, and then I can do puts, which will take the string from the hello world and print it to the screen, right? And he has definitely made it pretty well, but yeah, I want to see if I can reach this much, right? So let's quickly make a directory called north, and the reason I'm calling it north is because it's neither Porth nor is it fourth, so it's north, right? And let's just quickly open it up in Helix, right? And let's open, actually, let me quit. And I can do cargo init dot because I want to make it in uh, Rust. So let's open it in Helix. Let's see what's up here. All right, that looks good. Let's just start this, and you can't do that. Wow. Okay. And cool. So um, let's start the development. Before before I start with the language, I want to actually start with start with the virtual machine for the language because I want it to be interpreted first, and then we can move on to compiling it later because I'm not very familiar with assembly. So let's just make the runtime, right? So let's make a struct, call it the runtime, and the runtime needs to have a stack because this is a stack-based programming language. And the stack is just a vec of data, right? So now what is data? So let's make an enum called data, and uh, we'll just say that data initially has a quad word, right, which is a U64, and we can eventually go ahead and um, give it more stuff in here, such as a byte, a word, and a D word, double word, right? So this is what I want to go for, essentially. Um, right. So let's start with the basics, right? So ample runtime, and what I'm gonna do is new. So let's make a new runtime, and stack is a vec new, right? So let's try to make a runtime. Select mute runtime is runtime new. Okay, and let's run it. So we can make a runtime. Now let's try to push some data onto the stack. So push quad, and we're just gonna do mutable self, and I'm gonna say uh, data is a U64, and then we can do self dot stack. How do you accept this? What? Never mind. I wanna push data colon colon quad with the data. So we have push quad and pub1 pop quad. So mutable self, and we get back EU64, and self dot, I guess I want to make it an option. Self dot stack dot pop, right? So it gave back a data. That's a little bad. Ah, I don't know, I don't feel like thinking too much right now. So some data, if it's some data, hmm, and we can say data is this thing, and then, hmm, I don't know. Right, okay, so this is an option of data, right? So what I'm gonna do is get rid of it, and then we can uh, essentially match on it. And now this is of type data, so I can just say quad value, right? And I guess I'm just gonna return the value in here, and that worked out. Okay, so I guess I can just do runtime push. Um, Actually, you know what? I'm just uh gonna do self dot stack dot pop, and do this, and we're just gonna change it to U64, I guess, right? And I want to push 34, and runtime dot push 35. Um, right. So it's quad, right? So now we can push, and I guess I'll just get rid of this. And right, so I don't really care about unused stuff. So we're gonna do this. Then I want to add some more instructions to it. So the first few instructions that I want to add are push, and it's going to take some U64 that we want to push. Then I want um, add instruction, which takes out top two items from the stack and then adds them and pushes it back to the stack. We'll do a sub instruction, maybe. No, let's just do print instruction, right? So let's see how we want to do this. Um, so let's say instruction. So enum instruction is push, add, and print, right? Um, then what we will do is function execute instruction on a mutable self with the instruction being the instruction. We can do that, get rid of that, get rid of that, get rid of that for now. And what we do is match on instruction. We will do instruction colon colon push. So if it's a push instruction, it needs a U64. Sorry, not 43, 64. And um, what I can do is just insert the value that I want to insert, and we can just do self dot push quad. Fuck that shit. Push quad value. Then instruction add will essentially do um, we'll let a is self dot pop quad b is self dot pop quad, and then we're just gonna do self dot push quad a plus b, right? And we can just do inst print we can just do let a is self dot pop quad and print line a, I guess. And that should get everything done, right? Option U64 does not. So what I'll do is just insert some unwraps in here, and so that's fine for now. And now what I can do is, let's say let instructions is a vector. We'll say the first instruction is inst push 34, inst push 35, and then inst add and inst print. So this is going to be our instructions, and then I guess we can just do um, I guess what I'll do is I'll just put it in here. So execute program, and essentially it's going to be a mutable self, and I'm going to say program is just a vector of instructions, and we can do for instruction in program we can just do self dot execute instruction instruction. That works out. So we can just do runtime dot execute program, and let's just try to run it. It works. So it works. But now what I want to do is actually these unwraps are actually bad. I don't want to do that. So instead what I'm going to do is here um, I want runtime exceptions, right? So enum runtime error, and we'll do stack was empty, right? And then what we will do is map error e okay or, right, it's okay or, and we can just do um, type runtime result t is result of t comma runtime error, right? And then what we can do is just change this to runtime result. And here we're gonna do runtime error stack was empty. Does that compile? Okay, that compiles, that compiles, that compiles. Now I can just do runtime error of nothing. My bad. Result, right? So I can just do uh, and yep. So I can just give an empty result, and we can just do runtime result, and we can return empty. Okay, so that's cool. Now what I can do is let error um, and we will do is error. Um, I'll change this to result. If it is error, then I just wanna print the error. Let's do runtime error and error, right? So this should print the error for us if we need it. And here I'm just gonna do in this compiles, right? My bad. Uh, Actually, I'll just change this to and we can just do this as error, right? Um, Else, let's just say ln and let's just do cargo run. So program executed successfully. And now if I just comment this out, right, and then I do cargo run, it should say runtime error, stack was empty. Great. So, well, we are done with the initial program that we wanted to do. So we just wanted some data to go on the stack, that is our runtime stack, and we wanted some instructions, right? We wanted some instructions, right? So we have got push, add, print, and so on. And we've got um, errors. The stack was empty is an error, which works and it's going pretty well. Now what do I want to do? How about we try to convert this program to a text format, and then we can read the text format, parse it correctly, and do the rest, right? So this would be something like 34, 35 plus and dot, which is what uh, Soding used, right? So let's just quickly make um a file over here. Um, Above, I do not know how to make a directory. So let's make their tests, right? And let's open new vim again. Let's go to tests and let's make a file called first dot north nt nh north. Hmm. First dot no nor. Sure, whatever, north. And we'll do 34, 35 plus dot. And let's go back to main. Now let's change this to North programming language. Right, so now let's get the argument. Right, so it's args, std and vargs. Sure, args dot. We want to skip one and take in next. Right, and we'll just do else println. Please provide a file to execute, right? And then what we will do is simply we need to convert that into instructions. So for let's just do read line, right? So let contents is fs, my bad. We can do use std env args and use std fs. Um, Read to string, and we want to give it the name, so we'll do arg. And I'm pretty sure this is a result type, so I can just do OK and insert println failed to read the file. Right, so now we have got the contents, and then I can do contents dot lines dot for each, right? And we get the line. And what I want to say is line dot split with spaces. I don't know if this is correct or not. We want to split it with spaces and then for each word in our thing, what I want to do is word is a string, so um, we'll just do let mute program is an empty vec word, and then I just want to do word to instruction, and then this could give us this could give us an error, right? So what I'm going to do is if let OK instruction is word, then push instruction, else invalid instruction word. I think that should do it. Right, maybe, maybe. So I can do, and then. Good enough, right? So now there's some error, right? So we do need process exit, right? So exit one, use std process exit. Right now word to instruction does not exist. So we'll do func word to instruction, and we take a word that's a string, and we return a result of instruction or empty, right? Uh, match word, right? So x, if x that starts with, mm, don't want that, bruh. This is annoying. Okay, let's see. Okay, so let first character be word dot chars dot next dot unwrap, right? And then now what I'm going to do is dot, okay, or I guess just that is fine, right? That's how I used okay or, right? Yeah, that's how I used it. So if it's empty, it'll just give it an error. I do plan to make this better later, but for now, I guess this is fine. Mm, now what I can do is if first char that is ASCII digit, what I want to do is um let's just say let number is word dot pass u64 dot map error to, right, so it's map error itself. Map error to, I don't care what you give me, it's going to be an empty error, and we'll just return it out. And then what I'm going to do is return okay inst push number. This is done. Otherwise, if we reach here, then I'm just going to do match word, and I'm going to say if it's a plus, then just give okay inst add. If it's a dot, then just give okay inst print, and for any other one, just give an error. And our program seems to be working. Please provide a file to execute. Good. Cargo run tests first north 69. So now space code. Bro, I don't know, bro. Edit tests first dot north. Okay, why did this happen here? Bro. Edit source main rs. Leave, and did I not go there? Okay, and now I can do edit tests first dot north. Good, so we have this thing, and I guess what I can do is 200 to 20 plus dot and cargo run tests first dot north And we got 69. Oh, my bad. My bad, my bad, my bad. Right, so what I'm gonna do is get rid of this and do program, right? And then what I can do is cargo run tests first north, and we get 69 for 20. Good, good. This is looking good. And I feel like I have done the same amount of work that Soding did on his first episode, so I'm gonna end it here. And I guess in the next episode we can try and make it better. Let's see how we can do that. But I guess this is it for the first episode.